The purpose of this video is to review the 4 questions from yesterday's lesson and check to make sure that you understand how to find the answers to those 4 questions. The first of the 4 questions was, how do you know if you use trigonometry? And there's 3 things that must be true about the problem in order for you to be able to use right triangle trigonometry. Number 1, you must have a right triangle. Number 2, you must know one reference angle. And number 3, you must know one side of the right triangle. Which picture includes enough information to use right triangle trigonometry? If we look at answer choice A, it is a right triangle. Do we know a reference angle? We do not. So triangle A is not the kind of triangle where we can solve for a missing side by using right triangle trigonometry. If we go to triangle B, it is a right triangle. And we know not only one reference angle, but 2 possible reference angles. Now the third question we have to ask ourselves is there a side that we know? Do we have a known side? And we do not have a known side. So we cannot use triangle B, or we cannot solve triangle B by using right triangle trigonometry. If we look at triangle C has a 32-degree reference angle. It's a right triangle, and we do know that one of the sides, the hypotenuse, is 24 feet. This triangle, triangle C, is a triangle where we could find a missing side by using right triangle trigonometry. Again, the reason is it is a right triangle, we do know a reference angle, and we do know one side. If we look at triangle D, it's eliminated because it is not a right triangle. Number 2, which picture includes enough information to use right triangle trigonometry? Number 3, which picture includes enough information to use right triangle trigonometry? The second question from yesterday's lesson was, how do you know which trig ratio to use? This is how you know. When the label on the known side and the side you must find are the opposite and hypotenuse, you use sine. When those labels are the adjacent and the hypotenuse, you use cosine. And when those labels are the opposite and the adjacent, you use tangent. Number 4, which trig ratio should be used to correctly solve for x? Before we can choose which trig ratio to use, we must label the sides of the triangle. So in this problem, our reference angle is 32 degrees. Our reference angle is made up of those 2 sides. The longer of the 2 sides is the hypotenuse, the shorter of those 2 sides is the adjacent, and the remaining side is the opposite. So in this problem, the side that we must find is the adjacent, and the side that we know is the hypotenuse. So if we take a look at SOHCAHTOA, and we look at the opposite side does not have a variable, and the opposite side does not have a length. So if we wanted to use tangent, we wouldn't have anything to fill in for the opposite side. If we wanted to use sine, we wouldn't have anything to fill in for the opposite side. But if we were going to use cosine, we could fill in the x for the adjacent side, and we could fill in the 24 for the hypotenuse, and we could use cosine to solve this problem using right triangle trigonometry. Number 5, which trig ratio should be used to correctly solve for x? Number 6, which trig ratio should be used to correctly solve for x? The third question from yesterday's lesson, how do you find the correct decimal value from the trig table? And the answer to that question is you find the intersection between the column with the trig ratio and the row with the angle. Number 7, use the trig table to find the decimal value of the trig ratio. And the trig ratio you're looking for is the cosine of 32 degrees. To find the decimal value of the cosine of 32 degrees, we need to find the intersection of the cosine column and the 32 degree row. So here is the cosine column, and here is the 32 degree row, and the cosine column and the 32 degree row intersect at 0.8480. That means the cosine of 32 degrees is equal to 0.8480, which also means that the adjacent side over the hypotenuse in any 31 or 32 degree right triangle will always come out to the decimal 0.8480. Number 8, use the trig table to find the decimal value of the trig ratio. And on this problem, the trig ratio they want you to find is the tangent of 21 degrees. Number 9, use the trig table to find the decimal value of the trig ratio. And on this problem, the trig ratio that they want you to find is the sine of 41 degrees. Here's the last question from yesterday's lesson. How do you solve the equation once you set it up? And you find the cross product and divide by the number in front of the variable to find the value of the variable. Number 10, use right triangle trigonometry to find the length of the side with the x. Before we can solve the equation, we need to write the equation. And before we write the equation, we have to figure out what trig ratio we're going to use. And before we can figure out what trig ratio we're going to use, we have to label the sides of the triangle. So 32 is the reference angle. These are the two sides that make up the reference angle. The longer of the two is the hypotenuse, the shorter is the adjacent, and the remaining side is the opposite. So in this problem, we are looking for the adjacent, and we know the hypotenuse. And so if we think of SOHCAHTOA, the adjacent and the hypotenuse is going to be cosine. So we're going to take the cosine of 32 degrees and find that decimal value on the trig table. I've gone to the cosine column and the 32 degree row, and the intersection of that column and that row is the decimal 0.8480. Now I'm ready to write my equation. I know that in every 32 degree right triangle, the adjacent side over the hypotenuse will equal the adjacent side over the hypotenuse. And in the triangle that we're working with, the adjacent side is x and the hypotenuse is 24. If we were doing a similar triangle problem involving two similar triangles, we would need to go look at the other triangle and write down the length of its adjacent side and its hypotenuse. But now that we know trigonometry, We don't need that other triangle because we already know that when we divide that triangle's adjacent side and hypotenuse, it will come out to the decimal 0.8480. So that is our equation. What most students do to solve the equation is they change it into a proportion by making the left side a fraction. Now we need to find the cross product. And in this problem, when we find the cross product, x times 1 is x. And when we multiply 0.8480 times 24, it comes out to 20.352. We're going to round that answer to the nearest hundredths place. So we're going to keep that much of the number, and we can see that the 2, which is the next number, will not bump up the 5 to a 6. So our final answer, the length of the adjacent side, is 20.35 feet. Problem number 11. Use right triangle trigonometry to find the length of the side with the x. Problem number 12. Use right triangle trigonometry to find the length of the side with the x.